Delta U is the change in internal energy, Q is heat energy, W is work done on the system. Temperature remains the same during phase transition from solid to liquid state, therefore no change in kinetic energy. However, potential energy increases as bonds are broken during the phase transition, therefore delta U increases. Like gases, work done by an external force is positive when solid contracts. This is because the direction of the force and direction of displacement is the same during compression. For the same reason, W is negative when the solid expands. Since W is negative when solid expands, Q must be positive in order for delta U to be positive. When solid contracts, Q must be positive if W does not provide sufficient energy for delta U. However, Q can be zero negative if W is equal or larger than delta U. For example, ice can melt when a very high pressure is applied on the ice. So the kinetic energy of molecule depends on the temperature. Therefore, there is no change in kinetic energy of the molecules when ice is 0 degrees. Changes to water at 0 degrees. The number of microscopic particles is proportional to the mass of a substance. For a fixed mass of 1 kg, the number of microscopic particles is fixed. In this case, the average potential and kinetic energies of these particles determines the internal energy of the substance. As given the table, the potential energy of all the molecules in 1 kg of ice and water at 0 degrees Celsius is 0 joules and 3.36 times 10 to the power of 5 joules respectively. Latent heat of fusion is the amount of energy required to increase the potential energy such that ice can become water. Hence, the specific capacity of fusion of ice, L, is 3.36 times 10 to the power of 5 joules per kg. This is consistent with the change in internal energy for the 1 kg of ice given by delta U equals to 3.36 times 10 to the power of 5 joules. Work done by 1 kg of water, W equals to P delta V, and that is 1.6 times 10 to the power of 5 joules. From first law of thermodynamics, delta U equals to Q plus W, we get L equals to 2.26 times 10 to the power of 6 joules per kg. There is little change in volume when the ice changes to water, but a large change in volume when water changes to steam. Thus, there is a substantial work done when water changes to steam, meaning more heat input is needed for the work done required for expansion. The specific latent heat of vaporization of an object is therefore higher than the specific latent heat of fusion.